Good day everyone! I am Sir Alkrismit. Welcome to my channel where fun and learning really do exist. Kung bago kayo sa akin channel, huwag kalimutang mag-subscribe, hit the bell para laging updated sa aking mga videos, i-like, share nyo na rin sa mga friends nyo, and mag-comment na rin kayo. So now, let's begin! So today, we will discuss about Unit 1, Earth and Space, Module 1, Plate Tectonics. In this module, you should be able to describe the distribution of active volcanoes, earthquake epicenters, and major mountain belts. Number 2, describe the different types of plate boundaries. And number 3, explain the different processes that occur along the plate boundaries. Of our very first lesson, what is plate tectonics? Earth's lithosphere consists of layers, the crust, and the upper part of the mantle. This part of the module will focus on the outermost layer, which is called the crust. The crust is made up of a variety of solid rocks like sedimentary, metamorphic, and igneous rocks. As you can see in the diagram, so this is the lithosphere. Lithosphere is composed of the crust and the upper mantle. The crust has two types, continental crust and the oceanic crust. Another diagram, so we have the continental crust, the sedimentary deposits, oceanic crust, the lithosphere, plastic asthenosphere, and the upper mantle. The crust has an average density of 2.8 grams per cubic centimeter, and its thickness ranges from 5 to 50 kilometers. The crust is thickest in a part where a relatively young mountain is present and thinnest along the ocean floor. There are two kinds of crust. Again, the continental crust, which is thicker but less dense, and the oceanic crust, which is relatively thinner but denser. What is plate tectonics? According to the plate tectonics model, the entire lithosphere of the Earth is broken into numerous segments called plates. This is the map of the different plates. As you can see on the diagram or in the map, we have 7 relatively large plates and number of smaller ones. The plates move very slowly but constantly, and this movement is called tectonics. Thus, the theory of moving lithospheric plates is called plate tectonics. So what are the different plates on the map? So we have the large plates, which are the North American plate, the Pacific plate, the Antarctic plate, the South American plate, the Eurasian plate, the African plate, and the Australian plate. So we have also small plates like Juan de Fuca plate, Cocos plate, Caribbean plate, Arabian plate, Nazca plate, Philippine plate. Yan. Before we study more about plate tectonics, let's discuss first one of the consequences of moving crustal plates, which is crucial in studying plate tectonics: earthquake. So remember that the plates are moving. They are moving slowly but constantly. So of course, if the plate is moving, there will be an earthquake. You have learned in your grade 8 science that an earthquake releases 3 types of seismic waves: the primary, the secondary, and the long surface waves. The first 2 waves, the primary and the secondary waves, travel into Earth's interior, while the last one, long waves, on the surface. These waves travel at different velocities, thus do not arrive at a seismic recording station at the same time. One is slower, the other is faster. The farther the recording instrument is from the focus, the greater the difference in arrival times of the first P wave compared to the first S wave. So remember that the focus is the origin of an earthquake. So since P wave and S waves have different velocities, primary wave will come first and then followed by the secondary wave. The difference in the arrival time will tell us the distance of the earthquake's focus from the seismic recording station. However, it does not tell it in which direction it came from. That's why if we have at least 3 recording stations that can tell how far away from them the earthquake occurred, the epicenter can be determined using the triangulation method. It uses distance information from 3 seismic stations to locate the earthquake epicenter. So we will use the triangulation method to locate the earthquake epicenter. And how is it done? Step 1. Determine the distance in kilometer of the earthquake epicenter from each of the seismic recording station using the recorded primary, secondary intervals. To compute the distance of the epicenter from each station, use the formula D equals TD divided by 8 seconds times 100 kilometers, where D is equal to the distance of the epicenter from each station in kilometers. TD is equal to time difference in the arrival time of P wave and S wave in seconds. Example, if the time difference is equal to 33 seconds, how far is the earthquake epicenter from this station? So to compute that, we have D equals TD divided by 8 seconds times 100 kilometers. So we will use this formula to compute for the distance. So let's substitute the given value, which is 33 seconds for the time difference. So now we have D equals 33 seconds, the given TD, divided by 8 seconds times 100 kilometers. Evaluate 33 seconds divided by 8 seconds, it is equal to 4.13. So we cancel seconds, because seconds divided by seconds is equal to 1. 1 times 4.13 is 4.13. Then multiply to 100 kilometers. The answer is 413 kilometers. So distance is equal to 413 kilometers. So this is the distance of the earthquake epicenter from a given station. After we computed the distance of the earthquake epicenters from the 3 seismic recording stations, we will now do step 2. Determine the distance of the earthquake epicenter from each of the seismic recording station on the map in centimeters. So this computed distance in centimeter will be the radius of the circle. To compute for the distance on the map in centimeters, we have this formula, distance of epicenter from the station in kilometers times the given scale, equals the computed distance in centimeters. Example, the scale is 1.5 centimeter is to 200 kilometers. For every 1.5 centimeter in our drawing, it is equivalent to 200 kilometers in the real world. So if we have the distance of epicenter in kilometers that we computed a while ago, which is 413 kilometers, we will multiply that into the given scale, which is 1.5 centimeters divided by 200 kilometers. So the answer will be 3.1 centimeter. So 413 kilometers times 1.5 centimeter divided by 200 kilometers is equal to 3.1 centimeters. This 3.1 centimeters will be the radius of the circle. So again, This is just one of the values that we must have. So we will compute also the distance of the epicenter in centimeters from the other two recording stations. So we will have at least 3 values. Step 3. On the map, draw a circle in each recording station using the computed distance in centimeter as the radius of the circle, being the station as the center of the circle. So on the map, circles are drawn around each seismic station. Remember that the computed distance in centimeter will be the radius of the circle. So if the recording stations are Puerto Princesa, Iloilo, and Jolo, so we will draw the 3 circles using the 3 values in centimeters as their radius. So where is now the earthquake epicenter? The 3 circles intersected at one point that locates the earthquake epicenter. So the point of intersection of the 3 circles will be the location of our epicenter. So where is the earthquake epicenter on the drawing? So based on our example, the earthquake epicenter is in Sulu Sea. Because again, the point of intersection of the 3 circles drawn on the map will be the location of the earthquake epicenter. And that is triangulation method. What is the difference between figure 1 and figure 2? Okay. Figure 1 is the map of the different plates. Figure 2 is the map of our geographical world. We have the different continents and the different oceans. What do you think is the basis of dividing the world in such manner? How do we have this kind of map? This is the map of the different plate boundaries. Determining the location of earthquake epicenters plays a vital role in laying the foundation of plate tectonics. Let us see how early geologists used the plotted positions of earthquake epicenters throughout the world in conceptualizing crustal movements. So I have here 3 maps. The first map is the map showing the distribution of earthquake epicenters, indicated by the yellow marks on the map. We have also the red circles or the red dots that indicate the location of active volcanoes. And also we have the shaded region on the map that indicates the mountain ranges on the world. So again, we have this map. We have this map of plate boundaries. And again, how do we have this map of plate boundaries? What is the basis of having this kind of map? So let's find out. Volcanoes, earthquake epicenters, and mountain ranges are mostly found in the same places on Earth. The places on Earth where most of the earthquakes originated, or some mountain ranges and volcanoes were formed, mark the boundaries of each lithospheric plate. As you can see on the map, showing the distribution of earthquake epicenters, the yellow marks, active volcanoes, the red dots, and the mountain ranges, the shaded regions, if you can see, they mark the boundaries of the different plates. Again, earthquakes, mountain ranges, and volcanoes mark the boundaries of each lithospheric plate. What does it mean? So we can find those three, any of the three, two of the three, in the or along the boundaries of the different plates. Geological activities such as occurrence of earthquakes, volcanism, and mountain formation are the basis of scientists in dividing Earth's lithosphere. So we have different lithosphere, we have different plates in the lithosphere because of these three geological activities. Again, we have occurrence of earthquakes, volcanism, and mountain formation. They are the basis of scientists in dividing the Earth's lithosphere into different plates. Ayan. So always remember that we have different plates because of those three geological activities. Plates are large pieces of the upper few hundred kilometers of Earth that move as a single unit as it floats above the mantle. So remember that the lithosphere is composed of the crust and the upper mantle, and the lithosphere is divided into several plates. Each plate moves slowly but constantly. The plates are in constant motion as they interact along their margins. Important geological processes take place along those boundaries of plates, and they are the formation of mountain ranges, volcanoes, and earthquakes. Okay, just remember the three geological activities: earthquakes, volcanoes, mountain ranges. They are found in or along the boundaries of each plate. Plates could either be a continental crust-leading plate or an oceanic crust-leading plate. So what does it mean? A continental crust-leading plate is the edge of the plate is a landmass. So when the edge of the plate is a landmass, just like this is the edge of South American plate, indicated by the red marking or the red line. This is a continental crust-leading plate because this is the edge where landmass is located. And the other side is called as the oceanic crust-leading plate. Why is it called as oceanic crust-leading plate? The edge of the plate is within the ocean. So the edge of this South American plate in this right side is located under the ocean. So that's why it is called as oceanic crust-leading plate. So again, it is continental crust-leading plate if it is an edge in the landmass, or if the edge is a landmass. It is called oceanic crust-leading plate if the edge of the plate is underwater. Ayan. So we have different types of plate boundaries. Since each plate is moving, we can categorize or classify the different plate boundaries into three according to how the plates move. So we have convergent plate boundary, divergent plate boundary, and transform boundary. So in the on the map, we have the different arrows that indicates the motion of the plates. So if the two plates are moving toward each other, their boundary is a convergent plate boundary. If the two plates are moving away from each other, their boundary is a divergent plate boundary. And if the two plates are sliding past each other, it is a transform fault boundary. So let's discuss each of them. So let's begin with convergent plate boundary, where plates are moving toward each other. So as you can see on the diagram or picture indicated by the two arrows are pointing to each other. So it means that this plate and this plate are moving toward each other. So their boundary is called as convergent plate boundary. So from the root word converge, which means to meet. Okay. Converging oceanic crust leading plate and a continental crust leading plate. So remember that a plate can be an oceanic crust leading plate or a continental crust leading plate. So what happens when two plates, one is oceanic crust leading plate and the other is continental crust leading plate, collide? Okay. The denser oceanic plate moves downward towards the mantle and it is called as subduction process. The subduction of plate can cause earthquakes at varying depths: shallow earthquake, intermediate earthquake, deep earthquake. Since the mantle is hotter than the crust, the subducted crust melt, forming magma. Addition of water will cause magma to become less dense, hence allowing it to rise and reach the crust. And because of that, rising of magma gives rise to the formation of a volcanic arc near the edge of continental plate. And aside from that, trench is also formed. What is a trench? This is the trench which is called as submarine valleys, which is the deepest part of the ocean. And do you know that one of the deepest trench in the world is the Philippine Trench, with a depth of 10,540 meters. So in this boundary, again, this is a convergent plate boundary between an oceanic crust leading plate and a continental crust leading plate. So when they collide, the oceanic crust leading plate will subduct. When you say subduct, it will move downward towards the mantle. Why does it subduct? Because it is denser than the continental crust leading plate. When the plate is denser than the other one, it will subduct. When you say subduct, it will move towards the mantle. And if the edge of this crust reach the mantle, which is hotter than the crust, that edge will melt, forming magma. So that magma will rise because it is now less dense. So if the material is less dense, it will rise, it will move upward. So as it moves upward, addition of water to the magma will form volcanoes on the surface of the continental plates. Ayan. So that's the process when there is convergence of oceanic crust leading plate and continental crust leading plate. So how do we explain the processes that occur between convergence of an oceanic plate and a continental plate? During the convergence of an oceanic plate and a continental plate, the denser oceanic plate slides under the less dense continental plate. This process is called subduction process. How do we determine the consequences of colliding plates? Okay, based on the convergence of oceanic and continental, geological events will take place such as formation of volcanoes in the continental plate, formation of trenches in the oceanic plate, and occurrence of earthquake. So remember these three geologic events that happened when oceanic plate and continental plate collide. How about if we have two oceanic crust leading plates colliding or converging? Okay, so we have two plates which are both oceanic crust leading plates. So the denser oceanic plate moves downward towards the mantle called subduction process. So if the two oceanic crust leading plates collide, remember that their boundary is a convergent plate boundary. They are both oceanic crust leading plates. The denser one will move downward towards the mantle. And what do you call to that process? It is called as subduction process. So what will happen if subduction process occur? Of course, if the edge of that subducted plate reach the mantle, it will form magma. So the magma is less dense, so it will rise towards the top of the other oceanic plate. Addition of water will cause magma to become less dense, hence allowing it to rise and reach the crust. The volcanic deposits pile up until they break through the surface of the ocean and form a volcanic island arc. So it takes years to happen to form volcanic island arc. So as the magma rises on the oceanic crust, so continuous eruption, continuous deposits or piling of the magma until it reaches the top of the ocean. So volcanic island arc will be formed. Ayan. So aside from that, on the other oceanic plate, there will be trench. Trench will be formed. Again, trench is the submarine valley, and it is the deepest part of the ocean. So since we are talking about oceanic crust leading plates or two oceanic plates, and earthquake occurs on that, underwater earthquakes, especially the stronger ones, can generate a tsunami, a Japanese term for harbor waves, a series of ocean waves with very long wavelengths. So if the earthquake is strong enough, a tsunami will be generated. Remember that tsunami is a big wave. It can destroy anything. Yan. So how do we explain again the processes that occur between convergence of two oceanic plates? When two oceanic plates converge, they also undergo a subduction process. So remember that subduction process is the movement or the motion of the oceanic plate towards the mantle. When an oceanic plate is denser than the other one, it will subduct. And subduction process is the sinking of plate towards the mantle. What are the consequences of colliding two oceanic plates? So we have formation of volcanoes or volcanic island arcs. We have formation of trenches. We have also the occurrence of shallow, intermediate, or deep earthquakes. So remember these three geologic events that can be observed when two oceanic crust leading plates collide. So again, what is the type of plate boundary between the two oceanic plates? It is convergent plate boundary because they move towards each other.